Morning, one and all. Welcome to today's session on Python programming. That is modules. We'll discuss about modules. This particular topic comes under module 2 of your syllabus. Let me see what are the contents of today's class. We'll discuss about modular approach, why, how modular approach, what are the built-in modules, how memory is represented when you import a module that we'll discuss, and how to use a particular module. We'll take an instance of a math module and we'll work and we'll also come to know how to import module another style from import. There is another style. We'll discuss that also, how to import a module. And moving further, we'll work on some examples, and at the end I'll give one assignment. Okay, so this is the agenda for the day. And coming on to first, we have given assignment yesterday. Happy to see most of you have done assignment. I checked. Okay. Again, okay, there are 57 in the sense, I think there are 2 entries, I think duplicate entries. Yeah, Shushma, 2 entries. And somewhere I saw there were 2 entries. That's the reason. I'm happy to see that all 55 students have submitted. So hats off. It's a big clap to one and all. You're really working very well. I'm really happy about your interest, and I want to encourage you in the same direction, and let me also make you, keep it up. Keep it up. Okay. The assignment was this one: age and BMI we had to import, and we had to tell whether your health risk is low, medium, or high. Okay. Most of you have done correctly, but let me give my style. Most of you have used AND operator. So without using AND operator, how to do? Nobody has solved. Okay. So this is one way. If age is less than 45 and you're checking with BMI. So if it is less than 22, low. If it is more than 22, medium. If it is more than 25, more than 45, so it is medium, and risk is high. So this is one way of doing it. Of course, you have to import age and BMI. Okay, that is import statement that you have to use. Another method is, this is the another method. Look at here. I'm just storing age. I'm storing the age that is less than 45 in young, BMI less than 22 in slim. So the computation result, the comparison result, I've already stored in 2 variables, young and slim. And I'm using, if you're young and slim, your heart attack rate is low. If you're young and not slim, medium. If you're not young and if you're slim, okay, medium. If you're not young and not slim, very high. So this is a kind of different style of writing, and this one I think nobody has done it. So that's why I want to show my style of coding it. So remember, every time when you write a program, see that you should write your comment on the top of the program. Okay, so that is required. And please take the screenshot. You can later you can write down. So you can try this method also. So that's the concept regarding yesterday's assignment. Most of you have done. Excellent, wonderful, keep it up. Now, coming on to today's class. Today we have to discuss about modular approach, modules. So in Java, we call it as packages. In C, C++, we call it as header files. How you are importing header files, how you are importing packages. The same way, you can also import already stored data, stored methods and variables. And here we call it as the module. The package, we call it as module. So it's a library, it's a built-in library, I can say. Let us see what is a module. Module is a collection of variables and functions that are grouped together in a single file. Okay, so a package or a header file, how you are having in C and Java separate files. Here also a module can be stored as a single file, and it's a collection of variables and functions. And what is the name that you are giving? Yes, the name is same. .py is the name. Okay, anyhow, I'll show you, demonstrate you how to create your own module, how to create your own module also. Okay, right. The next thing is variable and functions inside the module are usually related to one another in some way. So generally, we store the module contents. We store the module contents in a single file, so that you know, they are related. The related file, related methods, related variables, you store it in a single file. So that file itself, we call it as a module, single module. For example, math module. So let me take example of math module. Math module, you have all the mathematical functions you know, stored. For example, there is a constant, you know, we have pi is a constant, and cos is a function, square root is a function, and just like that, there are many mathematical functions. All mathematical functions you group together and you store it in a module. So that is math module. We call it as math module. And this math module, you know, if you store it, it can be reused. It can be reused. It can be imported in multiple programs. And what happens when you reuse in multiple programs? So it becomes very easy for a programmer. It becomes very easy. Okay, he writes most common common functions and common variables or common constants in module, and he'll keep on importing that module, and he'll be reusing the same code. The main advantage of using the modular approach is reusability. Reusability is the first and foremost utility of this concept. Further, this particular chapter shows hundreds of modules that are there in Python. So, and also you can create your own module. Okay, you can create your own module, and you will see hundreds of modules. Python is very rich in library. The first class itself, one of your friend told, sir, Python is a rich in library. Python is a very rich programming language. It is very rich in library. Yes, that word is true. Definitely, it is very rich, and it is having hundreds of modules. And every day, somebody or the other will be contributing to this Python community new modules. They'll be creating and, you know, contributing. Further, how to import this module? So, importing module is very simple. You use a keyword called import. Import is the keyword and name of the module. You just give. To gain access to the variables that are there in that particular module, or functions that are there in that particular module, you have to first import that module. So how to import? We use import statement. Look at the last line. We use import statement. Import statement is the first statement that we have to use before actually we access to that particular module. So here is one example. Look at here, import math. Math is a module. And once we import, what happens? All the functions and all the variables, all the constants that are there in this particular math module will come to memory, Okay, and you can refer that variables, that constants, that functions as through math object. You create an object, and that object is associated with all the methods, all the variables, all the constants. So once you import, all the functions will convert it into methods, automatically methods, and it will create an object with that name math. So I think you have written object-oriented programming. In object-oriented programming, you know how to use how to call method inside the class, right? So if you want to call a method inside the class, what you have to do, you have to first create object for that particular class, and you have to call the methods using this object. The same way, when you import, what happens? Math object is created, and all the variables, all the constants, all the methods that are there in the math module will be associated with this object. And you can call each module, you can use each variable using dot operator. You can use it as dot operator, you can see. And if you want to confirm whether this math is an object or not, just type math. So when you do type math, it will show it is a class module, and it is what do you call it as the object. Let me show that live here. I just import, you can see, import math. Now a variable is created. Type math, I just give. Type math, if I give. So it is showing it is a class. It's a class. And math object is created. And you can access all the functions, that is methods and variables and constants that are there inside this module in object-oriented programming style. Okay. So once you import, you can use built-in functions with the help of the help function. There's a help function, I think we all know. When we use a help function, what happens? We'll come to know, the help details about all the functions. So here I can certainly give help math. So when I say help math, it will display all the methods, all the variables, all the constants that are there in this particular math, along with a short description. Look at there. So these E is a constant, inf is a constant, nan is a constant, pi value. You need not have to import pi. Create pi. Pi is already. Tau value is also, it's a constant. So these are all the data variables that we have. And you have truncate is a function, tan h is a function, tan is a function, square root is a function, sin h is a function, sine is a function, radians is a function, pow is a function, mod f is a function, log functions, and id xp is a function, is in function, is nan function, is finite function, is close function, is hypothesis, hypot is a function, gcd is a function. You need not have to find gcd. Separate function, it's already built in. GCD a comma b, you give x comma y some integers, automatically you will get the greatest common divisor. Same way, freq is a function, fsum is a function, floor is a function, factorial is a function. It's already available. Import math, say factorial of 5, it will give 120. It will give straight away. The factorial function, exponential function, degrees cos h function, ceil function. There are so many, a sine function, a cos function. So all the function, and a description about math function. This module is always available. It provides access to mathematical functions defined in C standard, defined by the C standard. Yes. See, it is also telling. So when you import any particular module, if you want to know what are all the functions, what are the variables, what are the constants that are available inside that particular module, you just give help and module name. It will show everything. It will show everything. So that is the beauty of Python, and we can certainly look at that. Help math. Any module you can import. Next question, definitely your friends will ask. Definitely, sir, how to know how many modules are there in Python? What are all the modules are there in Python? Correct, no? So after knowing about math module, definitely your mind will be thinking, hey, how many modules are there in Python? Yes, very simple. You give this command, help within double quotes modules. Go to idle again, help within double quotes modules, modules, modules within double quote, close bracket. So my system is having all modules. Anaconda, very big collection of modules. Okay, so it is taking a moment to list all the available modules. You see, please wait. This itself will show what are the modules, how many modules I have. See, it is still making a list, and this list goes on and on. So I have created user-defined modules and built-in modules, Anaconda modules. So whatever the new modules I get, I will update every now and then. So I keep on, updating my Python library. So I get a lot of modules, all the modules. And for my research also, I use a lot of Python modules to implement. Here the list started. You just see how it is scrolling. If you just count, I bet it is more than 500 modules. I bet. Yes, there are so many modules. Okay, there are so many modules. Zlib is a module, HTML is a module, HTTP is a module, RE is a module, random is a module. So each module has hundreds of methods and a couple of variables, couple of constants. It's very simple. And you see Rupa. There is a module called Rupa. It's already there. User-defined module. You can also create your own module, right? So probably at the end of this module, chapter, you should be able to create your own module and list it out in the, list of all the modules. Okay. Right. And particularly help math. And if you want to get all the built-in functions, I have already said built-in functions, dir __ built-in. If you give, you get all the built-in functions. So Python is having built-in functions. Apart from that, it is having lot of library modules, and inside library modules, there are a couple of. So these built-in functions are general functions, several general functions. Apart from that, you have specialized categories called modules, and inside that categories you have so many, methods, variables, and constants. Now, memory representation. How? What happens? What happens when you import math? When you import math, how? What happens? So, a statement import math creates a variable called math, and that refers to the module. So, when you import, a variable is created. An object, variable object is created. This is called math. And this is always referring to the math module. And of course, in that particular object, all the names defined in the module, and each of them refers to the function object. So if you just give import math, so what happens? See, first thing is an object is creating. It's an object is creating, and it is allocating a memory ID3 some memory allocate. In that ID3, what is there? You have name of the mod and all the methods that are there in math module. All the methods are stored. You can see I have put dot 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 dot. That means all the methods starting from ACOS till the last. And each method, each function, each method is having its own definition. Yes, its own definition. First function definition, second function definition, third function definition, fourth function, so on, so on, so on, so on, so on, so on. All the function till the last function. All the functions are created, memory allocated. It's a huge memory is created. Huge memory is created and allocated. See, when you import a particular module, all the functions that are there in that particular module plus the variables, the constants gets memory allocated, and they are all associated with math object. They are all associated with the math object. What a technology Python is having, right? And remember, it's a huge collection that happens within fraction of seconds. Okay, let me take you to Spider. In Spider, if I just clear the screen. Okay, if I type here import math, you can see anyhow it is having the variable list also, import math. You can just see math object is created. This math object is created. And not only math object, all the what do you call methods associated with math are also created. Such a huge memory is allocated. So that is the thing. Now, how to use math function? If you just say SQRT of 9, it will say, I don't know. I don't know what is SQRT. Because SQRT is associated with math. So you have to call the SQRT function like a method using math object. So then what you have to do, you have to call math.sqrt. Oh, then it will understand. Oh, yes, exactly. SQRT is associated with math. Okay, I understood. I will get the same thing. You can check here. So if I say, look at here. If I say SQRT of 9, it says name error. I don't know SQRT. I don't know who is SQRT. If you say math.sqrt, SQRT means that person available in math module, that fellow, then it will understand. Yes. Okay, then it will give the answer. So this indicates that the SQRT method is available with math only. It's available with math only, right? So that's very important. And dot operator is used. It means that it looks up the object that the variable has left for dot refers to, and in that object find the name that occurs to the right of that dot. It will refer. Yes, it will refer in math namespace, and in the math namespace it is available. Then it will refer to SQRT and then pass the value, and the result is brought back. So math.sqrt, Python finds math in the current namespace, looks up the module object that math refers to, and finds the function inside the math module, that is SQRT, and executes the function call and returns the results back. So whenever if you want to use area of circle or area of this one, directly import math.py is equal to 3.1415 something. So radius is equal to 5. Print area of circle is pi r square. Pi value you need not have to calculate. It is already there. Math.py, you reuse it into radius *2 radius square. Yes, I got that. So this is how you can use. This is how you can use. Right. So one disadvantage of using this kind is, see, you are using in this program only one math variable. You are using only one math variable, right? So you are using only math.py. But when you say import math, what happens? Entire math, all the functions, all the variables, all the constants will import. But you are using only one. You are using only one. Only this one you are using. Only for using only one, what you are doing, you are importing everybody. You are not using all. You are importing, you are using only one, and you are importing everything. So memory, unnecessarily you are wasting by importing. Am I correct? Hope you are all understanding. I'm using only one single function or single constant, but I'm importing everything. Simply unnecessarily I'm allocating memory, wasting. So is there any solution? Yes. In Java, what you will do? Java.io.star, import java.io. Particular method name you give. So it means only that particular method is imported. Only that particular component imported. Not everything. The same way in Python also, if you want only particular component, particular method, or particular constant, if you want to import, then you have to make use of from import. You have to make use of from import. This is another style. It's another way, another style of doing it. So look at here, combining modules name with the names of the things that it contains is safe, but it is not always convenient. For this reason, Python lets you to specify exactly what you want to import from that particular module, like this. From import, from math, you import only two, SQRT and Py, only two things are imported. Only two things, only two. One is SQRT and another one is Py. That's all. Nothing is imported. All other things will not get memory allocated. Only two. So this is wise way of doing the import. This is wise way. Okay, now when you import like this, math object is not created. Entire math object is not created. Only two functions are created, two components are created. One is SQRT, another one is pi. You can so directly you can use SQRT of 9. Directly you can use. Directly you can use. You can see pi you can directly use. SQRT you can directly use. Directly. You do not have to worry. Because only two things are important. Not the entire math object is important. Only two components. So when only two components are important, so you can certainly, they are imported as their native name. SQRT as SQRT, pi as pi. So you can straight away use SQRT of 9, 3 points. Pi, you can straight away. 2 pi r square, 2 pi r, sorry, is a circumference. Yes, you can easily do it. The advantages, you can save memory. You can save memory and it will be very convenient. It's very fast also. You need not have to import a lot of things. Only little bit import. And in the namespace also, math object is not created. But using math, you are importing. SQRT separate function is created. Pi separate constant is created in the namespace, and you can straight away directly you can use. So you can directly use. So when you use from math import, if you do it, if you call like this, it will throw error because you are not importing everything. You are importing only SQRT. And of course, when you import separate SQRT function, separate pi variable or constant is created, and their values, their definitions are imported into the memory. Only two. So which will definitely gives a lot of advantage. And usually it is not a good idea to import everything because everything we are not using it, but for our convenience we will use. In the initial stages we'll use, but later when you are writing perfect programming, you have to use. So instead of importing like this, so if you want to import everything from math, so from math import star, if you just give, that's sufficient. It will import everything. DIR function I have already told, it will list all the contents. Yeah, so all the contents that are there in the DIR function. So here, so it will display all the functions and variables that are available. So DIR function is also being used. DIR built-ins. Let me give you one example how exactly it can be used. Math. So first, let me generate a calendar. There is a module called import date and time, and we create an object called time. Date and time dot now. So we are getting current date and time, and print that date and time. So this is to just print. So this is a 3-line code. What I do, I just copy and paste this 3-line code so that how we can use. So very simple. Just copy these 3 lines and let me execute it in Jupyter or Anaconda. Anything is fine. So yeah, here better the spider is better. I just yeah, delete it, make it big, paste. Yes, you can run this. Okay. Yes, it is displaying 2020 9/28 9 o'clock 34 minutes 55 seconds 0750 180 18 milliseconds. So it is displaying. It's displaying. The time, date and time is displaying. Another example that I would like to give is a calendar. If you want to generate a calendar, import a calendar and give year, give month, and display the calendar. Just print calendar.month YY, MM. It will display the calendar. You can see, you can display a calendar like this. So it's displaying a calendar, right? I'll just copy it. Let me run this code. Yeah. When I run this code, sorry, I have not put input statement. So it is displaying September 2020. Yeah, look at this. September 2020 calendar is being displayed. It is same as your cal command in Unix, which I have taught you the previous semester. So it's just like that. And similarly, you can do many examples. I can show you one example, compression. Anyhow, this I'll explain tomorrow. It requires explanation. So similarly, you can plot a graph. So I'm running short of time. Please note down assignment for the day. So you have to write a Python program to find square root, roots of a quadratic equation. Roots of a quadratic equation, and indicate whether roots are imaginary, equal, or real. So I have to do this. Okay, here combination of if statement, combination of modules are required. Yes, combination of if statement, modules are required. Yes. Please type in your USN in the attendance in the chat box. Thank you, Chandrasekhar, for noting down the attendance. As of now, 50 students are being attended today's class. Yeah. That's all. I think we'll, meet tomorrow's class. In the tomorrow's class, I'll be explaining two more examples, which are very important. If you're working on data science project, those two examples are most important examples. Okay, so in the next class, we'll be defining about, we'll be discussing about defining our own function, what happens during import internals, and how to update imports, and we'll also discuss docstring. I've told in the functions, during functions, a topic, I explained what is docstring, same docstring. You can certainly reuse it. It will definitely make a lot of impact. Okay, that's in the next class. And thank you. Be safe. All the class recordings, your notes, everything is available in my website.